Hello, this is Bhavani, Assistant Professor in IT Department at SMIT. We are going to see about the artificial intelligence and machine learning. Moving on to approximate inference in Bayesian network. Approximate inference eliminate probability. It used when exact inference is infeasible. Large network require approximate methods. Okay. They provide faster result. Approximate inference is scalable. It is useful in real-time system. Many AI applications rely on approximate inference. Okay. Why? Because it is used when exact inference is computationally infeasible. Approximately methods trade accuracy for efficiency and provide results that are closely to the true probabilities. Why we need to know that why approximate inference is needed? It is because it is due to expensive large number of variables, dense network structures, high tree width, and then real-time constraints. This also refers that approximate inference allows fast probabilistic reasoning under uncertainty. Okay, we should know about the types of approximate inference method. First one will be sampling based method. Okay, it's nothing but it's generating samples from the network. In that, it's subdivided into prior sampling, which are generated according to prior probabilities. Evidence is ignored during sampling, and then subdivided into rejection sampling, which improves prior samples by handling evidence. We have three steps for rejection sampling. Step 1, it generates the sample from prior, and then we need to reject samples that do not match the evidence. Use remaining samples to estimate the probability. Third, likelihood weighting. Okay, fixes evidence variable, assign weights to sample instead of rejecting them. Moving on to Markov chain Monte Carlo, it's a kept sampling, nothing but samples, each variable conditioned on others, builds a Markov chain that converges into true distribution. Second will be variational inference. It converts inference into an optimization problem, approximates true distribution with a simple one, and then it minimizes divergence. Okay. Actually, we need to know when to use the approximate inference. Why? Because without knowing that, we cannot use the approximate inference in Bayesian network. Actually, see, when large Bayesian networks are used, and then real-time AI system, robotics and perception, medical diagnosis system, online learning, and then reasoning. And then with the use of approximate inference, the advantages will be scalable to large networks, faster than exact inference, suitable for real world AI application. Okay. Next, sampling methods. Sampling methods are common approximate inference techniques. They generate sample from probability distribution. Monte Carlo sampling is widely used. Actually, more samples improve accuracy. Sampling handles large network efficiently. It avoids complex computation. These methods are flexible. They are popular in machine learning. Actually, let us see detail about the sampling methods. It's nothing but used to estimate the probabilities in Bayesian network, another probabilistic model. When exactly inference is too expensive, they work by generating samples from a probability distribution and using a frequency counts to approximate required probabilities. Likely, we need to know about why sampling methods are used. Because of exact inference is NP hard for larger networks. Networking may have many variables and dependencies. Real-time AI system need fast answers. Generating some ideas of sampling, generate many samples from the network, count how often event occurs, use relative frequency to estimate probability. Okay, main sample methods would be prior sampling, which has been discussed before. They generated according to prior probability. Evidence is not considered for sampling methods. And then rejection sampling improves prior sampling by handling evidence. Okay, procedures will be followed of three procedures. One will be generate sample using prior sampling, reject samples that do not match the evidence, use remaining sample for estimation. Third one will be likelihood weighting. Like see evidence variables are fixed and each sample is given as a weight. Okay. Fourth one saying of Markov chain Monte Carlo, give sampling. Samples one variable at a time and condition on all other variables. Okay. Moving on to Markov chain Monte Carlo. It is a sampling method. It's one of the sampling method which has been discussed before. It constructs a Markov chain of samples. The chain coverages to the target distribution. Give sampling is a popular MC technique. It's updated one variable at a time. It handles complex distribution. It is widely used in Bayesian inference. This method supports approximate reasoning. Causal networks. This model cause and effect relationship. They extend Bayesian networks with causal interpretation. Edges represent direct causal influence. Causal reasoning support intervention analysis. It helps answer what if questions. These networks are useful in decision making. They are applied in healthcare and economics. Causal model improve explainability. Okay. Probabilistic reasoning in AI. Actually, this enables the intelligent behavior. It allows system to reason with uncertainty. AI agents use it for prediction and planning. It supports learning from data. Many AI techniques rely on probability. This approach improves adaptability. It is essential for real-world AI system. Probabilistic reasoning bridges logic and learning. Then probabilistic reasoning in machine learning uses probability for modeling data, handle noise effectively. They estimate uncertainty in prediction. Bayesian learning updates model incrementally. Probability classifiers are widely used. They improve generalization. This approach enhances robustness. It's fundamental to the model in machine learning. Applications which used in probabilistic models are used in many domains. Examples include medical diagnosis and research, speech recognition. They support spam detection and recommendation system. Robotics uses them for localization. Finance applies them for risk analysis. They enable intelligent decision making. These models handle uncertainty effectively. Their application continue to grow. Let us conclude this unit 2. Probability reasoning is vital in AI and machine learning. It provides tools to handle uncertainty logically. Bayesian inference updates belief with evidence. Navy Bayes offers simple and efficient classification. Bayesian networks model complex dependencies. Inference techniques support reasoning tasks. Causal network enhances understanding. And these concepts form a strong AI foundation. Thank you.